There is a bridge in rural Pennsylvania that has been carrying continuous traffic for 140 years. Not pedestrian traffic. Not the occasional horse cart crossing a quiet country road. Continuous vehicular traffic. Farm equipment. Loaded freight trucks, the full weight of modern agricultural and commercial use, applied daily to a structure built in 1882 using tools and techniques and materials that the engineers who designed it did not fully document. Because they did not think documentation was necessary. Because what they were doing was what bridge builders did. Because the knowledge of how to do it lived in the hands and the judgment of the men who built it rather than in any written specification that needed to be preserved for future reference. That bridge is still standing. The technique used to build it is not fully understood by the engineers responsible for maintaining it today. They can observe what was done. They can measure the results. They cannot fully replicate the process. And that specific bridge is not unusual. It is one of hundreds of pre-1880 structures across the United States that continue to perform at or above modern engineering standards despite being built using methods that contemporary structural engineering cannot completely account for. I found this while researching the infrastructure history of the American interior. Following the trail of construction projects from the mid-19th century whose performance records consistently exceeded what the documented engineering principles of the period should have allowed, I expected to find a story about the romantic overestimation of historical craftsmanship, about nostalgia producing inflated assessments of structures that were actually less reliable than modern engineering but benefited from survivor bias. After all, the bridges that failed in the 19th century are not standing today. Only the ones that succeeded are still there to be studied. The survivor bias explanation is real. It is a legitimate methodological caution that any honest examination of this question has to acknowledge. But it does not fully explain what the structural analysis of surviving pre-1880 bridges consistently finds. The official story of American bridge engineering in the 19th century is a story of progressive scientific development. Early bridges were built using empirical methods derived from craft tradition. As engineering became a more formalized discipline through the mid-19th century, mathematical analysis gradually replaced craft intuition as the primary basis for structural design. The emergence of professional engineering education, the founding of the American Society of Civil Engineers in 1852, and the development of standardized testing methods for construction materials all contributed to a more systematic and scientifically grounded approach to bridge design. By 1880, the transition from craft-based to science-based engineering was substantially complete. The great iron and steel bridges of the late 19th century, the Brooklyn Bridge, the Eads Bridge across the Mississippi, represent the full flowering of scientific engineering applied to large-scale infrastructure. That story is accurate in its broad outlines. What it does not fully account for is the performance record of the bridges built immediately before that transition. The timber and wrought iron structures of the 1840s, 1850s, and 1860s that were built by men who were operating at the cusp between craft tradition and emerging scientific method. Using techniques that drew from centuries of accumulated empirical knowledge that had never been formally documented, and that in many cases has not been formally documented since. Here is what structural engineers who have examined surviving pre-1880 bridges report when asked specifically about the joinery techniques used in the timber components. The connections between structural members in the best surviving pre-1880 timber bridges are not fully explicable by reference to any documented engineering principle of the period. They work. the load distribution they achieve, the way they manage stress concentration at connection points, the manner in which they accommodate the dimensional changes that timber undergoes across seasonal humidity cycles, all of this performs at a level that modern structural analysis confirms is correct. But the specific geometry of those connections, the precise angles and bearing surfaces, and the exact sequence of operations that produce them cannot be derived from any written source from the period, because no written source from the period describes them at this level of precision. The knowledge was transmitted not through documentation, but through apprenticeship, through the direct transmission of technique from experienced builder to apprentice, through the kind of embodied knowledge that lives in the hands and the eyes and the accumulated judgment of practitioners who had spent decades learning to see structural problems in ways that formal engineering education had not yet developed the vocabulary to describe. Now here is where it gets strange. The transition from craft-based to science-based engineering that the official story presents as an unambiguous improvement produced, in the decades immediately following the transition, a generation of bridges whose performance record is notably worse than the craft-built bridges that preceded them. The period from approximately 1870 to 1900 saw a rate of bridge failure in the United States that structural historians have consistently identified as anomalously high. Not because the engineers of the period were less capable than their predecessors, but because they were operating with formal analytical tools that were not yet complete. They had abandoned the craft knowledge that had produced reliable structures for centuries. They had not yet fully developed the scientific knowledge that would eventually replace it. They were building in the gap between two ways of knowing. And the bridges they built in that gap failed at rates that the craft-built bridges of the preceding generation did not. The craft knowledge that produced the surviving pre-1880 bridges was not primitive. It was sophisticated in ways that formal documentation failed to capture, precisely because the people who possessed it did not think in terms of documentation. They thought in terms of practice. They thought in terms of the feel of timber under a handplane, the sound of a joint closing correctly, the visual assessment of grain direction and structural load that experienced builders made automatically and continuously throughout the construction process. That knowledge was not transferable through written specification. It was transferable only through the long apprenticeship that produced craftsmen who possessed it. And by the time formal engineering began asking questions that only that knowledge could answer, the craftsmen who possessed it were gone. The last generation of builders trained entirely within the craft tradition died during the 1880s and 1890s. Their apprentices, many of whom had been trained at the point when craft tradition and formal engineering were beginning to intersect, retained partial versions of the knowledge. Enough to maintain and repair the structures that had been built, not enough to fully document what they were maintaining or why it worked. And their apprentices, in turn, retained less. By 1920, the living transmission of the craft knowledge that had built the pre-1880 bridges had been broken. What remained was the structures themselves, performing according to principles that the engineers responsible for them could observe but not fully articulate. Several federal bridge inspection programs conducted since the 1970s have documented this problem in specific terms. Inspectors assigned to pre-1880 timber bridges have consistently reported that the structures perform correctly according to every measurable standard while using joinery techniques that the inspectors cannot fully account for in terms of current structural engineering principles. The bridges are not mysterious. They are not evidence of any lost technology in the dramatic sense that popular culture sometimes implies. They are evidence of something more mundane and more genuinely interesting. They are evidence that a form of knowledge that was never adequately documented was lost before anyone understood that it needed to be documented. Lost not through any dramatic destruction, not through any deliberate suppression, through the normal process by which knowledge that lives in practice rather than in writing disappears when the practice is discontinued and the practitioners die. The transition from craft to science in American engineering was presented at the time and has been presented since as an unambiguous improvement. Science replaced intuition. Systematic analysis replaced rule of thumb. Documented knowledge replaced knowledge that lived only in the hands of specific practitioners. The transition was genuinely beneficial in most respects. The large-scale infrastructure of the late 19th and 20th centuries could not have been built without it. But the transition also destroyed something. A body of knowledge about how to build structures from wood and iron that had been accumulated across centuries of practice, that had produced structures whose performance record in some specific categories exceeded what the science that replaced it could initially achieve. And that was never adequately documented before the last generation of practitioners who possessed it in its complete form passed out of the profession. The Howe Truss, the Burr Arch Truss, the Long Truss, the Town Lattice, the structural forms developed by American bridge builders in the first half of the 19th century are documented in their geometry. The specific techniques used to fabricate their connection details, to assess and select their timber, and to manage the construction process in ways that produced the performance record those structures achieved, that knowledge is documented only in the structures themselves, and in the gap between what the structures do and what current engineering can fully explain about why they do it. The bridge in rural Pennsylvania is still standing, still carrying traffic, still performing according to principles that the engineers inspecting it can measure but cannot completely account for. The men who built it have been dead for over a century. The knowledge they used died with the last of the people they transmitted it to. What remains is the bridge, doing what it has always done, in a way that nobody alive fully understands. And the question of what else was built with that knowledge, and what we lost when the knowledge that built it was allowed to disappear without being documented, is a question that the official history of American engineering has never been required to answer. Because the official history of American engineering is a history of progress, and the things that were lost in the transition to progress are not part of that story. If you want more videos like this, make sure to subscribe to the channel. I'll see you in the next one.